Hello everyone, good morning. I hope you guys are doing well. This is Shreyas here, your master teacher for physics, and today, like I promised you, I'm going to discuss the drills of Newton's laws. So remember, last week we have completed Newton's laws, and today, just like I promised you, we're going to discuss the assignment, the practice problems which I gave you, yes, on the friction and Newton's laws, the pseudo forces, all those things combined. So I had made an amazing assignment for all of you, and I'm pretty sure you would have solved it by now. So let's get ahead with the discussion. And for those of you who are very new to this channel, JEE Enthuse, remember this is a JEE English channel by Vedantu for all the students who want to learn physics, chemistry, maths and prepare and crack the JEE examination and want to learn in English medium. All right, so this is me, Shreyas. I have been teaching for quite some time now, and I am the anchor for this channel, and I also teach in the long-term courses at Vedantu. So I have produced a lot of great ranks, and I have been training kids for quite some time now, and I have prepared amazing questions for all of you, and I train you guys in the evening with the theory part, the numericals, the examples, etc. That's what we conduct in the evenings, and we give you the assignments so that you can solve it, and after a day or two we discuss them. All right, so let's begin with the discussion. And in case you're new, do not forget to subscribe to our channel so that you do not miss any video from our side, and also do not forget to like us, because those are the fees of our channel. All right, so let's get ahead and let's start with our first question out here, which says, if an object stays at rest as seen from some frame of reference, then which of the following is true? So let's try to solve this. Okay, now the frame may be inertial and resultant force acts on it. Okay, let's think about it. Rather than going option by option, I feel we should think, how would the FBD of that body look like? So a body stays at rest. So if this is that body, and if it stays at rest, what does it mean? That the net force acting on it is zero. So there could be some random forces acting on it. All right, maybe some forces from outside like normal, tension, friction, weight, etc. And there could be also a pseudo force acting on it. But if the pseudo force acts, it must exactly cancel out the other forces. So if the frame is non-inertial, then the pseudo force must cancel the other forces. This is in case of non-inertial frame. But let's say, for example, that the frame is inertial, then remember, in case of inertial frame there is no need of pseudo forces, so there might be other forces acting on it, but these forces, that is the net force, just cancels out from everywhere. These are the only two possibilities. Now it makes sense which option will be correct. The frame is inertial and resultant force acts on it. This is obviously wrong. The resultant force, if in case of inertial frame, think about it, in case of inertial frame, must be zero. So obviously A option is wrong. The frame may be non-inertial like this one, and the real forces like these cancel out the pseudo forces. They are opposite but equal in magnitude. Yes, this makes sense. So this is true. The frame may be non-inertial, think about it, and resultant force acts on it. Well, I don't think so. Look at that. The frame is non-inertial. Is there a resultant force? No, they all cancel out. So obviously option C is wrong. The frame must always be inertial? No. The frame can be inertial or can be non-inertial. For each case we have different kinds of scenarios. So must be, this word is very important. If it said maybe, then yes, but must be, you are asserting that is not correct. So hence this option is also wrong. Alright, so that is the way to solve this particular question, and hence the answer for this is option B. I hope you have understood it now. So let's go ahead to the next question. So a slide loving kid, alright, he slides down at 45 degrees and he slides in twice the time he would take to slide down a frictionless slide of the same inclination? What is the coefficient of kinetic friction? Okay, so here is the thing. See guys, if there is a mass, okay, and if it slides down a smooth incline, let's assume this incline is very smooth, then the only force which is propelling it down will be obviously mg sine theta, and in that case there will be an acceleration. Let's say I call it a1. Say this a1, believe me, will just be g sine theta. That's it. There is no opposing force. Mg cos theta will be balancing normal. That's a standard FBD, and no friction, of course. So mg sine theta is ma. So a will be g sine theta. Okay, plain and simple. Now, how much time does it take to slide down? Okay, so let's say the distance of that slide is some L. So I can use S is ut plus half at square. So if I use S is ut plus half at square, I'll get L is ut plus half a t1 square. All right, and that will give me L is equal to g sine theta by 2 into t1 square. That's one thing I got. So I'll just keep it aside. I'm not going to do anything with it. I'll just keep it aside. Now let's go to the next part. When there is friction. Now when there is friction, what will be the change? The same mass, yes, is going to encounter mg sine theta downwards. Normal will be there, mg cos theta will be there, but there will be an additional frictional force. And how much will that be? It will be mu mg cos theta, because mg cos theta will be the normal force, right? Mg cos is here, normal is there, it will be balancing mu n. So this mg cos theta, understand, is actually normal, and it will have some acceleration, but this time it's going to be different because of this opposing force, and we can figure it out by using Newton's laws. So mg sine theta minus mu mg cos theta is equal to m into a2. Now you can do the math, it's not that difficult, and you will get a2 is g common because it's there everywhere, and I can take sine theta minus mu cos theta. That's what I'll get. But I believe, okay, theta was given to me, so I could have substituted theta over here as well. So let's do that and see what do we get. In fact, if I substitute theta as 45 degrees, I'll get L is equal to, remember sine 45 is 1 by root 2, so I'll get it as g t1 square by 2 root 2. That's what I will get. And over here I will get a2 as g sine 45 and cos 45 coincidentally are the same, so might as well take it out as common because coincidentally it's same. So 1 minus mu. Next, obviously use same distance is ut plus half at square. That's your kinematic equation. So L is equal to ut plus half a2 t2 square. So just substitute it, and therefore L will be equal to, I believe a2 is g by root 2, so it will become g by 2 root 2, but this time it will be t2 square. That's what I got. So I got, oh, and there is 1 minus mu, of course. Yes, I cannot forget that. G by 2 root 2. Yes, that 2 is also there. 1 minus mu is there, and t2 square is also there. Okay, fine. Now the only step remaining is, look at that, is given he takes twice the time when there is friction as compared to a frictionless slide. So which is the frictionless one? This one. With friction obviously comes down slowly, so t2 is twice t1. So just equate the two. L is same, so just equate the two, you will get everything whatever you want. So just equate the two, guys. So on the left side you will have, okay, one sec, g and t1 square by, this one is 2 root 2, and from this side you will get g by 2 root 2 again, and t2 square and 1 minus mu. But do not forget that because of this, it takes twice the time. Because of this word, understand T2 is twice T1. Now everything cancels out and you will get over here T1 square is equal to 4T1 square, 2 root 2, 2 root 2 gone, G also gone, and you got 1 minus mu. T1 square also cancels, so you will get 1 by 4 is equal to 1 minus mu. So therefore mu, think about it, is 1 minus 1 by 4, which is nothing but 3 by 4. That's the answer. That's how you're supposed to do this. It's quite a problem because it involves kinematic equations, it involves friction, Newton's laws, free body diagram, and also you have to equate the two different scenarios because the time is twice and then solve those equations mathematically. So it's quite a problem, but it's not difficult, so much at least. Okay, I hope you guys have understood this. Okay, great. Sure, let's go to the next problem. So the answer was 0.75 or 3 by 4, which we just got it. Now this is again an interesting question. So guys, it's very important that when you attend these discussions, you understand it in detail. I know these sessions are recorded, so all the JEE enthusiasts who are our regular users, please help others out. Alright, because that's what we stand here for. We have to help each other selflessly, hold each other's hands, help each other, keep arguing, discussing whatever it is in the chat box. I often read all your chat boxes, even of the recorded sessions, let me remind you. Okay, so maintain it, keep it civilized, and also help each other. Do not forget that. Okay, so let's go ahead. A man of mass this much kg standing on a weighing machine which is kept in an elevator kind of a box of mass 30 kg. So this box's mass is 30 kg, person's mass is 60. The weighing machine, neglect the mass. There is a thread which hangs over a pulley and the other end is held by the man himself. If the box is at rest, that's a keyword. What is the weight shown by the machine and what is the tension in the rope? Now whenever you see such questions, weight shown by the machine, all you need to do is find the normal force exerted on him by the weighing machine. That's all. So if you find a normal force and let's say it comes out to be 200 Newton, then the weight shown is 20 kg because 20 G is 200. So all you have to do is just find the normal force on the person by the weighing machine. That's all. So let's try to draw the free body diagram of the person. So that's what we need to begin with. So let's see what do we get. Okay. So, okay, now on this person, so there are different things whose FBD can be drawn. So I feel we can draw this guy's FBD, that will be better, and think about it, what and all forces are there only on the person. Understand, whatever I'm going to draw using red color will be the forces on the person, excluding the lift, excluding the thread, excluding the weighing machine, only the person. So one will be obviously the person's weight, 60 kg, so 60 G. You will be like, sir, why isn't the normal going to be 60 kg? Think about it. If he pulls the rope down, he will be pushed up. He pulls the rope down, rope pulls him up. Understand that. So whatever force he applies on the rope, the same force of tension pulls him up. That's the reason why the normal is not going to be 60 kg. Think about it. So when you pull yourself up, obviously normal will reduce. You will not have that much contact. So normal will reduce. So that's one thing. So keep that in mind, and hence nothing else is there. It's at rest. It's given somewhere. Yes, it's at rest. Everything is at rest. So keep that in mind. So therefore, I can clearly say tension plus normal minus 60 G is equal to 0. So that's one equation. Therefore, T plus N is equal to 60 G. That's equation number 1. Let's keep that in mind. Next, let's take, although I'm not writing, but in case you want it, I've just taken the Pandu or that person as the system when I wrote it in red. Okay, now whatever I'm going to draw in green, will be the FBD, yes, will be the FBD of only the lift, yes, only the lift, nothing else. You can include the weighing machine because it is massless, so no harm in that, but only the lift. So what and all forces are there? Well, the lift is attached to the thread, so there is that same tension T which will pull that lift of course upwards. Please do not show tension here because the thread is passing via a hole through that lift, so do not draw anything over there. Fine. What else? If normal is exerted on the person, a normal reaction will also be exerted on the lift. So that's action reaction. We have seen that Newton's third law. Lift exerts a force on Pandu, Pandu exerts a force on the lift. What else? Obviously the lift itself has a mass, box has a mass of 30 kg. Do not forget that. So I'm also going to show one extra force of 30 G. Just see if there is anything else missing. I believe not. There is nothing else missing. So according to this, when I have taken only lift plus that machine as a system, my forces will balance again each other. So tension minus 30 G minus normal is equal to 0. Rearrange. Therefore tension will be normal plus 30 G. That's my equation number 2. Now check this out. T plus n is 60. T is equal to n plus 30. I have two equations and two unknowns, of course, so it's easily solvable. So you can use tension's value over here. So substituting equation number 2 in equation number 1, just put that over there. So you will get n plus 30G plus n, this is plus n, is equal to 60G, of course. Now that will become 2n. Take that 30G there, it will become just 30G. Therefore n will be just 15G. So what will be the reading shown? The reading shown will be 15 kg weight. Alright, so the reading shown will be 15 kg. The Pandu weighs 60 kg, believe me, but the reading shown will be 15 kg. That 45 kgs is just wiped off just because he pulls the string up. That's all. Obviously, if n is 15G, right, if n is 15G, therefore tension will be 15G plus 30G. This is using equation number 2. That's what I got, and that is nothing but 45G, which is nothing but 450 Newton. So that's the tension in the thread. We have solved it. So what was the crux of the problem, one might ask? The crux of the problem was choosing a system wisely. If you do not choose a system wisely, you might just get confused. You should be able to visualize which body should exclude, which body to include. You should be able to visualize, okay, if I just consider this body, only what are the forces acting on that particular body. Remember, when you show FBD, forces should be shown only acting on that body, not by that body or on some other body. That is what we have done. And that's it. After that was just framing the equations and solving them simultaneously to get the desired result. There's nothing great about it. Alright, so that was the answer of this question, and yes, 15 kg and 450 Newton. Okay, this is also an interesting question. This guy is standing on a lift. The lift goes up, I believe, yes, with some acceleration, then moves with constant speed and then decelerates. Okay, so the maximum and the minimum recorded weights are this and this. What is the acceleration and what is the actual weight of the person? Both are asked. What is the actual weight and what is the acceleration? Now, in this question, first try to visualize. When the lift goes up, accelerates up, because of that acceleration, pseudo force will be down and weight will also be down, so that will add to his weight. He will see more reading. So that maximum reading 72 kg is seen when the lift is accelerating up. Okay, then when the lift moves with uniform velocity, understand uniform velocity means no acceleration. That means will there be pseudo force? No. That means what reading will be shown? True weight. But is that mentioned? What is the true weight? No. So in fact we have to find what is the true weight of the person. Great. Then the lift decelerates. Decelerates while going up, matlab acceleration is down. It's going up, speed is reducing. So obviously it's retarding or accelerating down. What happens when something accelerates down, guys? Think about it. In that frame of reference, if acceleration is down, think about it, pseudo force will be up. So weight is down, pseudo force is up, you will feel little bit less weight. And that's why the reading shown is 60 kg. So that's why you are seeing two readings. One is maximum, one is minimum, once while accelerating up, once while accelerating downwards. That's how it goes. Now let's solve the problem. The first thing was to visualize. I know equations are very easy for this problem, but I always make you guys visualize things. Now, when the lift accelerates up, the normal force is 72 kg. So 72 G is the normal force, and the weight will be mg plus a. Why g plus a? Because pseudo force will add with the weight. So I can just say 72 G is equal to m into g plus a. Okay, that's one equation. And my second equation, guys, will be when the lift accelerates down, then the normal force is 60 G and the weight will be mg minus a. That's all. Understand? mg minus a because it's accelerating down. That's all. So obviously 60 G is equal to m into g minus a. Now what do you want? I mean, everything is there. You just don't know a and m. Same thing over here, and you have two equations, two unknowns. Solve it, you'll get the answer. How to solve? It's up to you how you want to solve it. I prefer dividing both of them. I think that will be easy. So think about it. If I divide both of them, yes, if I divide both of them, what will I get? 72 by 60. Okay, GG cancels, will be also cancels, and I will have on the top something called as G plus A, and here I'll have G minus A. Now what will I do? There is a property called as componendo dividendo. It says if I have numerator by denominator is somebody else's numerator by denominator, then I can do this. I can take numerator, and before that I can do one more thing. Alright, I can do one more thing. I can just simplify this little bit. 72 goes with 12. How many times? I believe 6 times. And it goes with 60 5 times. And this G is actually 10. So 10 plus A divided by 10 minus A. And now using componendo dividendo property, I will get 6 plus 5, numerator plus denominator, upon numerator minus denominator is equal to 10 plus A plus 10 minus A divided by 10 plus A minus 10 minus A. That's what I'll get. Now simplify this. 6 plus 5 is 11 and 6 minus 5 is 1. That's it. A and A cancels, so 10 plus 10 is just 20, guys. This A and that A, minus and minus, will become plus. This 10 and that 10 will also cancel out, so it will become just 2A, and you can also cancel that 2 with this 2 and it will become 10. So guys, what will the value of A be? Think about it. A will be 10 divided by 11, I believe. So 10 divided by 11 meters per second square. That is the answer. Once you get the acceleration, you can easily find what is the mass as well from any of these equations. That's not a difficult task. but I hope you understood the main method. Alright, so you can substitute over here this as 10 by 11 and you can substitute this as 10. Obviously G is again 10. From this you will get how much this mass is. It's nothing great. Alright, I hope you guys have understood the method. The method is important. Mathematics, anybody can do it because this is pretty simple. Okay, so very important technique you learned. In case you don't know what is componendo dividendo, please read up on it because it's very important property. You will learn it in maths as well, in algebra. Okay, numerator plus denominator upon numerator minus denominator works many times. Okay, so that's the answer. Okay, so that's 0.9 approximately and 66 kg. That's what you will get. Okay. Now, this is another interesting question. A 26 Newton force is applied on the pulley as shown in the figure. If the coefficient is 0.4 between the block and the surface and the mass of the block is 2 kg, find the acceleration of the block. Okay, let's try and do that. Okay, so let's try to work on this diagram itself. Now the force acting is 26 Newton. If the force acting is 26 Newton, understand on this pulley there will be some tension, and if you just think about the free body diagram of the pulley, F minus T will be mass of the pulley, which is 0, into acceleration. So just forget about the mass because it's a light pulley. Even though it is not given, that's what we generally assume. So therefore, remember, it has been the case always, F will be 2T. So whenever you have a pulley being pulled from the middle, the tensions on the side will add up and give you the force in the middle. That's always been the case. So therefore, tension will be the force divided by 2. What is that force? It's 26. So divided by 2, that 2 has come downstairs and I'll get this as 13 Newton. Now, what do I do next? Well, the same tension will also act on this block. It's the same string, so same tension is going to pull that block. But do not forget, there will be also friction over here, and yes, there will be a normal here, and there will be also mg. How much is the mass? How much is the mass? The block's mass is 2 kg, so 2g force here. How much will be the friction? Since coefficient is 0.4, so this friction, guys, will be 0.4 multiplied by n, mu n, and the result of all of this will be some acceleration. So it will obviously have some acceleration there. So what is pulling that block? Tension. What is opposing? Friction. What is friction? 0.4 n. So I need normal. So how do I find normal? By balancing the forces. So from here, normal is just 2g, which is just 20 newtons. Now therefore, friction will be 0.4 multiplied by 20, correct? So that goes and you will get this as 8 Newton. So that's friction. Now for block M, you can say tension minus friction is Ma. That's Newton's second law. What is tension? We just figured it out. It was 13. What is friction? Well, that's 8. What is the mass? Where is it? 2 multiplied by A. So 13 minus 8, guys. How much is it? Come on, 5. So acceleration will be 5 by 2. It's 2.5 meters per second square. That's how you do it. Simple. So quite a few concepts. First, again, choosing system wisely. I chose pulley just to find tension, and from tension I was able to apply Newton's law for the block alone, block M, right? Without that I could not do it. Such a nice simple problem, but nice concepts are there. That's what is the speciality of the drills. It will make your mind think. In the sessions I will slowly gradually scale up the level of problems, and the drills are literally drilling sessions for you guys. Okay, chalo, let's go ahead. So 2.5 meters per second square. I hope you guys are enjoying. Please keep the enthu up, just like the live session. Help each other, keep chatting, keep helping, keep interacting with each other. That's very important. Bring in all the new users. Yes, bring in all the new people to the JEE Enthuse family, help them, yes, motivate them as well. All right. Okay. So next question. Okay. Blocks of so and so weight. A has a weight of 44, B has a weight of 22. What is the minimum weight of C to keep A from sliding and the table if the mu between block A and the table is 0.2. Okay, let's think about it. First of all, I don't want this block to slide. Who is pulling this block? This tension. Correct? This tension is pulling the block. Who is creating that tension? Think about it. This block B down there is creating that tension. So let's start with the free body diagram. That will make things a little bit simple. That's what we always do. There is this block B whose weight is 22. That's what is given. That is creating a tension. But remember, tension and this weight will be equal because it's not accelerating. So everything is at rest because it's given to keep A from sliding. So to keep A from sliding means everything is at rest. That's one thing that should be there in your mind. The same thread continues. So there must be a tension over here. What else? There must be a friction here. Now, why don't you guys just consider this entire thing as one unit? It's just one unit. Just think of it. They're not moving with relative to each other. Just forget that they are two separate blocks. Just one single unit. So if you think of it as one single unit, they will have a combined weight, right? That's a combined weight. I do not know how much it is. And they will also have a combined normal reaction. I'll call it N1. What else is there? Oh yes, there is friction, and friction coefficient is given. So I have to just prevent it from sliding, and I have to put minimum mass. So when I will be putting small as mass possible, then this friction is such that it's limiting friction because the system is on the verge of sliding. Atamaji Satakli types. Okay, it's on the verge of sliding, else this won't be limiting friction. So what is Fs max? It is nothing but mu, which is 0.2 multiplied by the normal force at this surface. Great. What now? Do I know the value of tension? Yes, I know the value of tension, and since it is at rest, therefore understand tension and Fs max should balance out each other, and this should be equal to 0.2 multiplied by N1. Tension is 22 Newton. Therefore N1, guys, think about it, 0.2 is 2 by 10. That 2 cancels, so you will have 11. All right, and you will have this as 110 Newton, I suppose. All right, that's clear. Now once I get N1, understand N1 actually is the total weight but of A plus C. But of that, I already know A's weight. So what is A's weight? It is 44. So the only thing remaining is the weight of C. That is 110. So that's how you get weight of C. I hope this is clear. I hope this is clear. So that's it. You'll get the answer as 66 Newton. You got it. So just going reverse, we have got the answer. It's not that difficult. 66 Newton, that's the answer. I hope you understood it. Let's go to the next question. Very interesting question again. So let's see how to solve this. Pendulum hangs but in a trolley which goes up an inclination of 30 degrees. Yes, inclination of 30 degrees with an acceleration of 10 meters per second square. So think about it. When this goes up with an acceleration of 10, in this frame of reference, if somebody is in this frame of reference, obviously it's a non-inertial frame. So anything that you look, any body that you look inside this, you will have to apply, do not forget, a pseudo force in the backward direction. So there will be a pseudo force here, apart from tension, weight, etc., etc. All these things will be there, but even pseudo force will be there. So keep that in mind, and let's begin the solution. So let's keep it aside. Let's look at the bob. This inclination is same as 30 degrees. The string is going to go further down, and observe these things very carefully, because a lot of things are going to happen now. Okay, now first things first, I'll just drop a perpendicular that's needed. Then I will show the forces, and to show the forces, here we go. One, of course, is the tension, a lovely tension. And remember, I'm observing everything sitting inside that trolley. Yes. So the trolley is going like this, accelerating. So pseudo force will be like that. That's how pseudo force works. So pseudo force will be exactly parallel to this line. That's very important. And Fp will be mass into acceleration. But you know what I can do? This 10, why not take it as G? Special value. So why not take it as G? So I'll just take it as MA, but that A over here is 10. So why not call it mg? That's it. Understand, it's not weight, but I can replace it because of this special number, nothing else. Keep that in mind. Okay, what else? Weight is down, and that will also have two more components. I'm already splitting it. Okay, so in case it doesn't look parallel, so yes, so one component like this, it will be mg cos 30, and another component that is mg sin 30. Great. What else is remaining? Let me choose some angle. Okay, let me choose some angle. Let's say this is theta, so even this is theta. Okay, these both are theta, guys. I hope this is clear. Okay, alternate angles. Cool. Now what do we do? Just, it's all about equations. Trust me, it's not that difficult. If you understood this free body diagram, now that bob is at rest. If it is at rest, all the forces should cancel out each other, guys. And let's see how they cancel out. Because if you notice, this tension has a component here, and that will be perfectly balanced by mg cos 30. Observe that. So tension cos theta, okay, will be balanced by mg cos 30. That's one equation. And this tension will have a component here, which will be tension sin theta. Okay, and there are two forces here. One is the component of the weight, which is mg sin 30, and one more force, which is just mg. Actually, it is pseudo force. This one is Fp, think about it. But that special value made it look like gravity, but I know value wise it is same, nothing else. Now what do I do? Okay, let's divide, guys. Let's divide both of them. So I'll get sine, I'm just dividing sine theta by cos theta. That will be a nice tan theta number. And when I divide, okay, this is mg sin 30. So sin 30, guys, believe me, is half, and mg is just mg, and that whole thing divided by mg cos 30. So mg root 3 by 2. Best part, mg gone. Half plus 1 is 3 by 2, and this over here is root 3 by 2. 2 gone. 3 by root 3 is just root 3. Sine by cos is tan theta. Oh, excellent. This is so cool. I hope this is understood. This is going to give me just 60 degrees. But don't celebrate yet. No, it's not a time to celebrate yet. You'll be like, what the hell am I missing? Observe the question carefully. The direction of the string, that is the angle with the vertical. Which is vertical? Is this the vertical? No, this is not vertical. Understand, no matter how tilted the diagram is, vertical and horizontal never change. This is always horizontal, this is always vertical. That's inclined plane angle or inclined plane, and that is perpendicular to the inclined plane. So don't get confused. So the question is from the vertical. Okay, what do I do now? Well, not to worry. Do not worry. Theta is known, 60, and I believe now you would have understood what to do. You would have understood what to do now. Guys, come on, you should have understood it. What has to be done? Doesn't it look like my standard diagram, the trick I taught you in Newton's laws? If you are new to the session, watch all my sessions. I have taught a trick. Once you divide it into 8 parts, isn't this 30 degrees? Think about it. This is 30 degrees. Even this is 30 degrees. Even this is 30 degrees. Even this is 30 degrees. Oh, my bad. Okay, one sec. So this is 30 degrees, and this is 30 degrees, and this is 30 degrees. I think now it's fine. Yeah. So each of these angles are 30 degrees because of this angle being 30 degrees. This much is 30, and this entire angle, yes, this entire angle is 60. How much is the angle made by the vertical? I believe you have found out the answer now. Okay. Okay, 1 second. I think I have marked a wrong angle out here. 1 second. Although, okay, the angles look little bit clumsy, so that is causing some problem. So let me mark it again so that there is clarity over here. This entire angle is theta, okay? And then we are talking about which is 30. This is 30. Forget the string, guys. String is not a part of that 8 parts. Forget that string. If that is 30, this is 30. By mistake, I marked that as 30. I'm so sorry. This is 30 degrees. Now it looks fine. Forget that string. Just think about that 8 parts which we usually make. So this is 30, this is 30, this is 30, and this is 30. So that is what I have marked. Okay. So if this much is 30, this much is 60, then this is also going to be 30. So the correct angle with vertical, yes, is going to be 30 degrees. That's the correct answer. A lot of people mark 60 degrees. That's not the correct answer. What a problem. What a problem. It's full of geometry, angles. You must realize that how important geometry is. Whatever you have studied in 9th and 10th. Without that, it's going to be very difficult. So that's the answer. Wow, what a problem. This is the last question. I hope you guys are still enthused, still listening. I know these problems are very good. I kept it good because I felt like giving these problems. This problem is also there in H.C. Verma in different ways. Alright, but no harm because it's a good problem. So this system is going to move. Find the acceleration of the block of this mass 2 kg. Okay, so guys, first let's visualize how it looks like. This mass, small m, though it looks small, where is it? Bigger block, is anything else given? Okay, 2 kg coefficient of friction between the 2 blocks is also given. The bigger block and the ground is this. The smaller block has mass, yes, 8 kg. Okay, maybe this is made of iron, and because it is made of iron, it looks small. Maybe this is made of wood or something, so it might look big, but the mass is very small. So it's fine. Just because it looks big does not mean it has more mass. This heavy thing pulls the string down. Once the string gets pulled down, the string moves over the pulley like this. And once the string moves over the pulley like that, it pulls this string over like this. And once this string gets pulled, it pulls this block like this. Okay, it pulls this block. So what is happening is, as this block moves, this pulley will also move, and as soon as this pulley moves, one extra string will fall down. So this mass fell down, but as soon as it moved, there is some string which is free, which falls down, and not only this block comes down over here, but this block pushes it over here, so it comes on here as well. So the visualization looks like this. Observe it. Very interesting visualization. This block moves here, and you can see some amount of string which was here has fallen down. It has gone down. Actually, I have not shown the block move down, but actually it should move down. That's one mistake in the diagram. I can correct it probably later on. So I'll draw it again, don't worry. This should actually move down. Now, it's a crazy problem, but don't worry, we will solve it. First, think about the free body diagrams and think where are you going to draw it from. Alright, so let's start. If you draw FBD, there is nothing difficult in it, believe me. So let's start. Okay, so let's look at the bigger block. If I look at the bigger block, but the bigger block's mass is just 2 kg, remember, okay, that bigger one. So the forces acting on that will be, well, one is obviously 2g, one will be obviously a normal, I'll call it N1 from the ground, and because the block slides towards the right side, obviously the friction, I'll call it F1, and wait, the coefficient of friction between the two blocks is mu1 and between bigger block and the ground is mu2. Okay, since between bigger block and the ground is given to be mu2, so I feel it's better to call it N2 and F2, because then F2 will be mu2 N2. So this 2 mu2 is between the ground and the bigger block, so I'll stick with that same nomenclature. What else? Do not forget there is a tension which is pulling it like this. So tension here. In fact, why not also include the pulley on the top inside the system, because the pulley is massless, else you'll have to consider a reaction of the pulley, which will make it very difficult. So just draw a tension down and a tension here. Okay, but that's not all. Yes, that's not all. In fact, this block is actually not here. This block has actually moved down. Please understand that. This block actually has moved down. So because this block is sliding down, on small m, the friction is up. But on big M, the friction is down. In fact, small m is scratching it down as it moves down. It's scratching it like this. So friction on this bigger block is downwards by that smaller block. So a lot of people forget that friction. So I'm going to show a friction F1. That's because of that smaller block downwards. And there will be also a normal force between them. Do not forget that. So also show a normal N1. Look at that crazy diagram. I think that's the only thing remaining. Yes, these are the only forces. Yeah, I'm calling it only. Okay, then look at that other block. Okay, let's look at that other block of mass 8 kg and let's think what are the forces acting on it. The forces acting on it are tension from the top, 8g from the bottom, a normal from this mass like this, same normal N1, friction reaction. So F1, remember M is moving down, so on it the friction will act upwards. Okay, and where are you sitting and observing it? It depends. Where are you sitting and observing it? See, I feel that if you sit on the ground and observe it, it will not move down. Think about it. Because it's not just moving down, but it is also being pushed ahead. So actually speaking, the acceleration is this way. Yes, if you did not realize it, it's actually accelerating that way. So why complicate it? Sit on capital M and observe it. Yes, it's better to sit on M and observe it. But where is M accelerating? Towards this side. In fact, I have to show the acceleration of M to be A. So if M is a non-inertial frame accelerating that way, there must be a pseudo force on it like this, which will be mass into acceleration of the frame, which is AT. Crazy problem. I know it's difficult, but I'm pretty sure you would have given it a try. If you are seeing this problem for the first time, obviously you should not see it. You should first try, else this session will be very tough on you, because you guys are preparing for JEE Advanced. If you are preparing for JEE Advanced, you need to put in that much amount of mental effort, that hard work, etc. You cannot just say that this problem is hard, oh my god, I'm not understanding. If I'm going to say that it's going to be hard, it's going to be tough, you will not understand it. But if you're going to make an effort, obviously you will understand it. You make that effort, make it, you will get it. You have to try and convince yourself. I'm not going to sit and convince you guys. You have to sit and convince yourself. Believe me, it is possible. It's not that difficult. So I'm sitting on M. When I sit on M, the advantage is I'll just see the block go down. Yes, the block might be moving with me, but I won't worry about it. And I am myself a non-inertial frame moving this way, so pseudo force will be that way. Then won't the 8 kg have some acceleration? Of course it will have some acceleration, but the problem, the next catch is it won't be A. You'll be like, what the hell, now this was the only thing remaining? Yes, the acceleration won't be A. Why won't it be A? Think about it. When this block moves here, think about it, this point has come here. There is a supply of string. How much supply? Let's say X. Did you see that? When the block, this big block moved here, X string went over the pulley, came down. Not just that, even this much part, it has come down over here like this. There is more supply of X amount of string which has come over here like this. So how much did this M actually go down by? Think about it. It has actually gone down by 2x. Yes, that's the trick. So this block moved, it has supplied X string, plus this string also was supplied because this also will fall down. So it has actually moved by 2x. So this, if it is A, this should be 2A. That is the complete FBD of this problem. Now that's just the FBD. Obviously we are not done yet. You have to write the equations, but that's not the difficult part, trust me. Okay, trust me, it's not the difficult part. You just have to write down all the equations and you'll get the answer. Yeah, what are the equations? Okay, for this one, in the x-axis, what will be the equations? Think, pseudo force and friction, normal will balance each other. So N1 will be balanced by Fp, and Fp is nothing but AT. In the y direction, think about it. Okay, 8G minus tension minus F1 will be equal to 8 into 2A. But that also can be simplified, because 8G minus T minus F1, well, where is mu1? Mu1 is 0.2, it's given 0.2. So use this value 0.2. So it will become 0.2 N1 is equal to 16A. You can use the value of N1 from here to here, right? So that's something which you need to do. Just substitute it over here, okay? And you can simplify that. That's one set of equations, okay? Keeping it aside. Next, look over here. Think what are the forces in the x-axis. Be careful. Be very, very careful. Okay, so there is T and T over here. So 2T. Okay, so 2T, T and T. And there is normal, so minus N1. And there is F2, minus F2. And what else is there? I hope I have not missed on any other force. Yes, just observe. I believe I have taken everything. Okay, I think I have taken everything. And this is nothing but 2A. Now, this F2 is mu to N2. And this N1 is 8A, right, from there. So 8A minus F2. F2 is mu 2. Mu 2 is, where is it? 0.1. And N2 is equal to 2A. So please understand, again I have used the value of N1 over here. Okay, so that's what I have done. Okay, now that's what's in X. Similarly, you can make an equation in Y direction. In the Y direction, think about it. What are the forces? There is one force N2 up. What else is there? What else is there? Friction is down. This tension is also down. 2G is also down. So N2 will be balanced by F1, then this tension, and what else is there? F1, tension, and obviously the weight, so which is 2G. That's it. Now whatever N2 you get, you put it over here. Okay, and obviously this F1, we just know it is nothing but mu N1. Where is that? Yeah, where is mu1? Yes, 0.2. Again N1. N1 is there. So look at that. How many places N1 is needed? Now you just solve it and you will get the answer. That's it. There is nothing great. Believe me, after this there is nothing. You just have to solve it. It looks difficult. Trust me, you do it, you will get the answer. It's not that difficult. Why did H.C. Verma give this problem? Because there are literally all the concepts involved over here. Constrained motion, yes. Pseudo force, yes. Friction, yes. Choice of system, yes. Tensions, yes. FBD, yes. Pulleys, yes. Moving blocks, yes. What more you want? And so many confusing equations. What more you want? This is by far one of the best problems of H.C. Verma and in Newton's laws, of course, and friction, which gives you a holistic view of this chapter. It's not, understand, the crux of the problem is not solving these equations. The crux of the problem is getting these equations. Solving anybody can do. Believe me, if you sit right now, you will solve it within the next 5 minutes. That's not the important point. The point is getting them, understanding how M is moving this way and all that. Alright? So that is the answer. So once you solve them, you will get the value of A. The value of A, I believe, comes out to be 3.44 meters per second square. That's the answer. What a session it was. Amazing session. I loved it. Personally, I loved this session. It's so cool. Such nice concepts. I hope you too have enjoyed this session. Do not feel demotivated by hard problems. You have to do it. That's why we are here. Nobody gives you these kind of detailed solutions, especially video lectures. Very well, nobody gives you. If you ask, in many coaching institutes, I've seen that they don't even tell you the answers. They don't even discuss the solutions. They just tell you, okay, you have to do it using a non-inertial frame. That's not what we are here for. We want you to be helped by us. And you can also join our Telegram group so that you can get all the updates. Okay, so this is our Telegram group. It's also there in our description link. And if you have enjoyed my discussion today, do not forget to like, and all the new users, do not forget to subscribe, and also do not forget to share all these videos with your friends if you think it will be useful. That's it for today. Thank you very much. That was Shreyas here, and I'm signing off. I hope to see you again tonight in our regular sessions. Bye bye. Take care.